perfectly valid C. It doesn't make sense to be perfectly valid C, but it works. It compiles. You can write it today if you wanted to. I learned today that you can make 2 equals 3 in Python. You can literally write code and you can say 2 equals 3 and Python will return true. Nothing else. Like you can have your prompt, type 2 equals 3, and it will say true. The intricacies of the language are pretty necessary to understanding and being proficient in the language. Objective-C, this is one of my favorites. You can create and modify classes at runtime. You can do whatever you want. You can replace methods, you can add properties, you can do whatever you want. And I know these things because I've worked with language for so long. In iOS, long double, which is normally a 128-bit type, is actually a 64-bit type. For some reason, Apple decided to ignore people. They ignored all the standards, and they made long double equal to double. And that's that. After a while working language, you know these intricacies. And once you know the intricacies, you actually can begin to master the language and become proficient in what you do. Language familiarity. This is a big thing. So you can be the greatest programmer at C. And if you touch Python, you'll be like, I'm not sure what I'm doing. And you'll write some Python code. People will be like, why are you writing it like that? Why are you not using the range operator? And or whatever that range function is to go through loops. Like, why are you doing what you're doing? People like look at you and like, this is weird. Like, he's a really smart programmer. Why is he doing these things? Languages are different. Languages behave differently. You don't really understand how they do things. So the greatest programmers will know why their language works the way it does. They will know how it works the way it does. They will know what changes have happened recently. And they'll know what it comes with. For example, SWIFT comes with a string type. SWIFT comes with an array type. Objective-C comes with nothing. Objective-C comes with a runtime function. There's no object. There's an object-based class. It doesn't really exist. You won't see it in the wild. C comes with a standard library. There's some extensions that come with the compiler that people don't really know about because GNU decided to add a bunch of extensions to the language which aren't really part of the language. It's important to know what your language comes with. So like if you were to write your language in the bare minimum in some environment, it's good to know what you have to work with. If you don't know what you have to work with, you can't really consider yourself someone who uses the language. Because you've been so privileged and sheltered by what you've been given. It's kind of like if you were to go into a warehouse and be like, where's the drilling machine? Like, why would we have one of those? It's just a generic warehouse. You need to know what you have and what you're working with. Language friends. This goes down to frameworks. This goes down to compilation tools, debuggers. You need to know about these things. You need to be able to use these things. You need to know that they exist. For example, I use C quite frequently. I know that GDB exists. I know that LLDB exists. I know that there are libraries for C that work. I know there are libraries for C that don't work. I know Objective-C, like I said earlier, Objective-C comes with nothing. It's just some runtime functions and that's it. Or Swift comes with a string type. If you were to compile Swift on any platform today, you have a string class. And that's that. It comes with it. You should know your patterns. Patterns are really important. Anti-patterns are also important to know. You should know that like random variables do not belong in random classes. You should know that about inheritance models. You should know about has-a models, is-a models, all of those kinds of things. You should know basically like why people are doing things the way they're doing. Like there is a thing in Go called Go routines. Go routines are like threads, but they're not really threads because they're like virtual threads sort of, and they're used to parallelize things in Go, and they're much faster than threads. And like it's important to know these patterns exist. Otherwise, you're trying to use threads and you're trying to do the wrong thing. Language was not meant for. So like if you were to use Python and you were trying to do GUI programming, you're probably doing the wrong thing. Python can do it, but it's not really meant for it. It's meant for like rapid prototyping. If you write C++ to try to do, C++ is everything, I can't even think of an example. If you were to write Julia to help make UIs, of course, you're going to have a bad time. Julia's not meant for that kind of stuff. It's like writing AI and R. Just don't do it. The process. I feel like an artist. Know the process. The process is important to know. Any programmer who's good at their art, go into a command line, they are working in that kind of environment, they create a new project quickly, and they can compile that project, they can run that project, they can run their code, they can see their code personally works. They know what to do to jump into a project very easily. There's no Googling, they know it, their memory, their muscles, their arms know it before their brain thinks about it. Knowing your assumptions. This is a big thing about programming. If you don't know your assumptions, you're going to write some bad code. If you know, for example, in a function that this function can never return a null value, you can continue on. You can keep going to C. Or else you're going to write code checking if it is null. And you have an issue like this. An error accrual is displaying a previous error. You shouldn't be checking if an error failed to present. Like, you should assume the errors always can succeed. If an error failed to present, it might as well just crash. Like, there's nothing you can do there. Assume that these things are going to work. Assume they're not going to work. Like, don't make checks for everything. Like, the application preview is not open anymore. Like, who wrote that error message? It doesn't make any sense. Like, I'm trying to open an application and it does this to me. Like, I click the file to open it and it says it's not open. Open it. I mean, like, who writes this message? Someone not, they don't think about the assumption that they can make. And someone actually had to translate this. They think 30 people translate this message to other languages. Like, it doesn't make any sense. It's like, they don't know what they're doing. You don't know what you're doing when you're not making, you don't know your correct assumptions. If the preview was not open, it should have been open. I clicked the icon to open the file. I clicked the file to open the application. Like, if it's not open anymore, it should open it. That's all it has to do. So someone's clearly not understanding what they're doing. Knowing the problems you're going to face. I'm going to write a program in C. I'm going to know that I'm going to have trouble with networking, making HTTP requests. I'm probably going to know where I'm going to have my biggest issues. I'm going to put them somewhere else to the side for now. And work on the core logic that I know needs to be done. Instead of playing games with things that I don't really care about, like networking. Like, I don't want to write my own HTTP stack in C just to get a simple program working. I'll put it aside later. Figure out exactly the problem you're trying to solve. There is a hypothesis somewhere on Wikipedia, I don't remember the name of, that every software is not complete unless an email client built in. And it's true. Emacs has an email client built in. You can get email working in Vim. All of these software people are just keep putting plugins in until you check your email. My IRC client can check my email. People do not know where they're targeting their application. They just keep putting wherever and wherever they feel like it. And I've had to struggle myself where I've written software, and I've constantly known where I was going to put. I've been asked to put new features, new features, new features, new features, and the core product wasn't done. So now I go into release and I have a half-finished product. It has a bunch of cool features, but I can't. It's not even like it's done. So you have to pick targets to stick to it. Minimum viable products are basically where you need to go to start. And from there you make it awesome. Otherwise you just make it work. The ideal process. So this is rarely whatever happens, but this is what you should want to happen. You should group and organize all of your program requirements. If you have a network stack, put it somewhere else. If you have a UI stack, put it somewhere else. Basically separate everything into the smallest possible components you can do, and make those things so small that it's impossible for them to fail. If you have a class that has to allocate strings, it's pretty hard to fail in allocating strings. Like, just make something small, and if it fails, you know it won't fail, so you know where to go when something's not working. All these debugging phases are a waste of time when you don't know what kind of code you're writing, what kind of code is going to compile. Half implement things. Don't get me wrong, half implementations are bad. But if you're going to write like a library to interpret some sort of API, just have it return temporary things for now. That way you can test things for sure, and you can know that things are going to work. Give it some random values to return like an array of 3 items. Go for it. But don't waste time writing like half the UI and half the network stack. Just have one of them do one thing, and have the other one just give you some fake data for now. Because that way you know exactly what's going to happen, and you're not debugging 2 or 3 things at the same time. And when you're refactoring 2 or 3 frameworks, you're having a bad time. And you're wasting time, and you're not necessarily sure what you're doing. And you have to finish one, you might finish one later, and then you have 10 more issues from where you started from. Context switches. This is a big problem in any area. When you're doing something, keep doing it. Take your 20-minute break, don't talk to anyone, go have some water, relax. Come back to what you're doing. That way you don't lose it in your head. Because when programmers like us are solving problems, we usually have 25 things in our head all at once, 25 different problems that we can't all solve at once. So as soon as someone comes and talks to us, it's gone. We've lost it, and now we need to come back and we need to actually read through the code trying to figure out what we actually were thinking of. We have no idea. So you have to like basically retrace your steps, try to figure out what you were thinking about, and now you've wasted another double the time you just spent. It'll be a little easier coming back to something, but it's not worth your time to keep wasting time retracing your steps. Do it all at once, call it a day. Computers have issues with context switches too. They're pretty expensive when you switch between processes, which happen every second or so. Because you can see you can only run one program at a time. Switch between 3 or 4 of them every few seconds, things like that. It's pretty expensive to have to keep switching a lot of things around, moving memory around. Context switches are generally bad. Do one thing as long as you can, then switch over. Of course, with computers, is do as many things as you can at once, and just keep doing that. So we're a little polar opposites here. Good programming. Yes?
I have like a really bad ADD, so sometimes like I'll take like visual notes when people are talking, and like paint little weird stuff on top of their heads. Is there anything like similar to that that you do to kind of map your, map your thinking as you go about digging into problems, and just in the case, or to protect yourself
So the ideal scenario is that your code has no comments in it, it's self-documenting, it's clean, makes sense. Whenever I walk away from something that I know needs to be finished, I'll leave a comment there like, this is what I was thinking, these are the issues I'm facing. Maybe I'll come back to it later, or realize I missed an assumption. And I can realize something I actually assumed was not true, actually is true. And I don't actually even have to write that code anymore. Basically, I can write like a small paragraph inside of code I was writing, and I can just have exactly what I was thinking written down, and come back to it later. And I do that a lot. I leave comments when I've made a mistake, or when something that has not, a thought process that has not cleared. Like I know once I finish something, it'll feel right to me in my head that I finished it, it's complete. The entire task is complete. But if I know that I have, and I know there's something still in my mental stack, I'll write a comment. I'll put something in my code and say, hey, this is what I was missing, this is what I'm thinking of, this is what's wrong. When I come back to it later, I'll read it, Jim will read it, Jim will tell me, hey, don't do this. And I'll be like, yeah, I know I shouldn't do it, I wrote down I shouldn't do it. And we'll all just know that we shouldn't do it. So it's very hard, like, Charles and I joked a few weeks ago about taking mental images of imaging our brain. One day we take like 4 or 5 things on our head, all stacked up, like all metaphorically stacked up, all things we have to do. And we'll go to sleep at night and we'll forget all the things we have to do, we'll sort of piece them back together. But it would be really cool if we could at one point just image our head and just restore the state. But of course that's pretty absurd, especially if the images are messed up. And I mean images with like large chunks of data, not necessarily visual images. And XCCD hard. Thank you. Any questions? Yes.
Why are there ones and zeros in art just like randomly?
I'm not random. Also, there's a slide for you to miss.
Okay. I bet it was really fun.
It was okay.
Oh, God.
I think there's a subreddit for spelling the Debian logo in random places.
I'm sure there is a subreddit for everything at this point.
That definitely happened because some dude stood in the middle of that and just like sprayed out the food like in a circle going farther out as he's like spun.
You don't know that.
I definitely do.
All right. Any other questions? Does anyone on the Hangout have questions? Where do I find the Hangout?
Oh wait, I didn't even read the title. Oh my God.